Okay, gang. This video is a continuation of the previous one. I was getting a little lengthy there, and it makes it just difficult to upload if the videos get too long, and I think too, it maybe gets a little boring. So what we're doing, this is a continuation of the previous video, and you know, at the end we realized that we had violated a lot of the assumptions. Again, the violation of the normality assumption concerns me a little bit. Violation of the equal variances, which, you know, these two violations, or at least, I'm sorry, the assumptions fall under the ANOVA heading. They were, you know, the equal variance was violated, slightly. Nevertheless, it was violated. Does that bother me? Yeah, a little bit, and you know, in combination with the normality assumption being violated. But the violation that concerns me the most was the one that we got at the end of the video, which was the violation of the homogeneity of regression slopes. Now, let me get my iPad going here. So one way to take a look at this is to examine the interaction variable. Interaction variables are not included in ANCOVA. ANCOVA interaction variables are when we have two categorical variables and we want to kind of come in and look at the marginal means across the subgroups of the two categories. That's not what we do in ANCOVA. ANCOVA, we're looking at a situation where we have a factor plus a continuous variable that we call our covariate. But nevertheless, the interaction variable, if it's statistically significant, then that means that we have reason to believe that we have violated the homogeneity of regression slopes. Now, I want to examine this more closely, and let me show you what I've done here. What I've done on my desktop is I have this file libido, but I also broke the libido down into just for high, just for placebo, and just for low. And I want to come in and look at the slopes of each one, and maybe get some more information. So guys, I'm going to do that with R, okay, as you may think. So first thing I'd want to do is set the working directory, and we should be really good at this by now. And I want to get my data. And I want to look at the placebo first. Attach my data. And you may want to look at it, but I don't care. I know what the variables are. I'll tell you what. Let me just show it to you, to show you what I've done. So what I've done is I've created a data set here only for the participants and their mates, the scores of libido, for those who receive the placebo. Now, the first thing I'm going to want to do is I'm going to want to create a model, a linear model, and I want to predict the partner's libido from the mate's libido. Okay, that's going to allow me to create the regression line. The next thing I want to do is I want to do a plot of the covariate mate over the partner, and I want to include the line of best fit for the model. Now this should do the trick, and when we get this, we can see that we have a slope that you know, looks like what we see. The reason I'm going over to the blackboard, and I'm going to create this. So it starts at about 1.5 and goes up to about a 6. Okay, so again, just to show you what I'm doing here. Okay. All right, just to show you what I'm doing here, I'm doing the placebo. Okay. Now, what I want to do, unfortunately, since I've got partner and mate, I'm going to have to shut this down. And I'm going to have to bring it back up. Set the working directory again. Get my data. And this time I want to look at the low dose. Attach the data, and let's just look at it. So what I've done here is I've just, again, nothing fancy. So I'm going to create my model here. So the linear model of partner from mate. And then I want to do a plot of my covariate over the partner. And ab line for my model. And in this situation, for the low, my line starts kind of negative and goes up to about 7. Now, keeping in mind, these are, this is sample. We're generalizing. So this is the kind of thing that I've done over here. Okay, similar slopes. Who knows? To me, there's not evidence to conclude they're not equal. Just from eyeballing. So I need to quit R again. And now I want to get into R again. So this is an R exercise, boys and girls. So set working directory. And let's get our data. And I think I called this high. Attach data, and let's just take a look at it. Okay, so those are the participants that had the high dose of the drug. So same thing, create my model, linear model, and I want the participant predicted from mate, and then I want to plot my covariate. Bingo. Aha. Well, guys, you don't have to have a PhD in statistics to okay, so I'm writing this down. A PhD in statistics to realize that something ain't right. Right? Now, statistically speaking, I can't, speak much about the first two slopes being different, but I think it's pretty clear that the slope of the third for the high is different. So this is a reason that we violated the homogeneity of regression slopes assumptions. So, guys, in the end, and I always say if I were being paid for this, because I've actually got 3 grants going on right now where I'm being paid for, being paid to analyze the data and participate in the research. So if this was something I came up with, the ANCOVA, I don't think so. So I would say the ANCOVA is not appropriate, and we've just violated too many assumptions. And again, the assumption of normality doesn't bother me as much as the homogeneity of variance doesn't bother me as much. But ANCOVA is just simply not appropriate when we violate the homogeneity of regression slopes. So, guys, I would go with something what we call a non-parametric design. And I don't remember exactly. I think the ones that is equivalent is this one, and I probably don't have that spelled correctly, but I think that's the non-parametric design that's similar to ANCOVA when assumptions are violated. So now, guys, I want to point something out to you. I talk a lot about a general linear model. And I started thinking the other day, do you guys really even know what I'm talking about here? In the end, a general linear model is just really saying that we have certain variation that we can explain plus certain variation well, pretend I spelled unexplained over here correctly. I can't handle that. And guys, I like to think about the general linear model as a, again, kind of a general model that can be viewed in the terms of regression and ANOVA. Now, I want to illustrate that for you. So what I want to do is I want to get back into R and just show you that at the end of the day, what we're doing in regression and what we're doing in ANOVA is pretty much the same. Now, the way I look at this is at the end of the day, you know, you guys, we're trying to get you ready to do your research. And typically research comes in two shapes and sizes, either quantitative research or qualitative research. Quantitative research, let's just think that deals with statistics. Qualitative research, you tell a story. And I had one time, actually, I have to admit I was guilty of this as well. Why would you ever conduct a qualitative research design? Well, after I've learned more about research, there are plenty of reasons. For example, a researcher I know wanted to examine the, I guess we would say the experiences of the first African-American law student at the University of Kentucky. Well, when you want to analyze the experience of one person, quantitative research doesn't work very well with one person. You can't very well work with means. There's no variation. Quantitative research is not appropriate in this situation. However, from one person, you could go in and tell a story. One of the most powerful research projects that I've seen looked at the experiences of female PhDs at the University of Kentucky back in the 1990s, even into, I guess this was about 1995. And it was very interesting, something we couldn't have done quantitatively, but it was interesting to look at the story. For example, there was a big fancy schmancy ball at the University of Kentucky, and the person went back and, again, telling the story in a qualitative fashion, and noticed that all the invitations that were sent to male professors were addressed as Dr. Doug Darbrow. All the invitations that were sent to female professors were addressed as Mrs. or Miss. Well, I would be outraged if I was a female, and I'm outraged even as a male. You know, that's something that, you know, we could have talked about the percentage of, you know, whatever, but at the end of the day, this is a story that needed to be told. Guys, I don't know much about qualitative research, so if you want to do qualitative research, you're going to need somebody other than me to teach you. But I do think I know a little bit about quantitative. So most of you, when you do your research project, you're going to do quantitative research. Now, quantitative research kind of comes in two shapes and sizes. Do we want to explain or examine relationships? Or do we want to create models that can be used for predictions? Well, guys, if we want to explain and examine relationships, then the ANOVA family does that for us. If we want to make predictions, then the regression family does that. Are these two related? They sure are, through what we call general linear models. Now, let me give you an illustration of this in R. So let's just pull up the data set libido. Let's pull up the whole one. So again, so working directory. This is getting kind of old, but what are you going to do? And let's bring up our data. Read.csv. libido.csv. All right, let's attach our data so we can look at it. And just to show you, this is the data set that we worked with in the previous video. Now, let's say, for example, that I wanted to run an ANCOVA. So this is going to be good. Now I'm going to call it fit this time. So just to run the ANCOVA, I would run fit. So I would do an ANOVA. It's part of the ANOVA family. And I would do the participant. And I would look at dose plus mate. I would realize that this gives me a type 1 sum of squares calculations. I prefer a type 3 sum of squares calculation. I don't like order to matter. So I'm going to use this whole drop 1 business. And I get my model. Okay? Now, let's run a regression. It's been a while, but hopefully you remember to run a regression. Back in 5500, we run a linear model. And I want to predict part from dose plus mate. Now, if I do summary of linear, let's see what we get. Now, first of all, you think something you got to remember is we're using a categorical predictor with more than 2 categories. So R has been pretty smart here and already set up our dummy variables. But your regression model has an intercept included. But what I want you to focus on is let's look at the p-values for mate. When I look at the p-value for mate in my ANCOVA, I get 0.03483. When I look at the p-value for the mate in my regression model, I get 0.0384. Guys, if you notice, remember our t-value squared is the F statistic. So, for example, if we take 2.227 and square it, we're going to get the corresponding F statistic up here. So the t-distribution squared is equivalent to the F distribution, creating the same p-value. We could actually get into the ANOVA. Actually, is it ANOVA for linear? Yeah. And what we can do there, is we can see, okay, I'm losing my place here. Okay, so for mate, we have sum of squares 15.076, which just conveniently shows up when we do the ANOVA for our linear model. So, guys, the reason I'm showing you this is to make a bigger picture, to show you that ANOVA's explaining relationship and regression, predicting values, is all related to what we call the general linear model. But I also want you to think about something we talked about in the video of covariance, and that's a covariate versus a continuous predictor variable. And if you remember what the difference was, if our covariate, we just want to adjust the variation for its inclusion in our model. A continuous predictor variable, we want to I don't know, I guess conduct a test of hypothesis. So when we do a regression model, then for mate, which is the covariate, we're allowed to come in and get an estimate, and we get a standard error, and we get a t-value, and we get a p-value. So mate's libido is statistically significant when controlling for dose in predicting the libido of the participant. Whereas if we're in the just ANOVA, and let me make sure I got this is the type 3 calculations, we can see that that mate is statistically significant in explaining the variation in partners' libido. So, guys, it's a lot of kind of the same words. The only difference, again, a covariate is something that we include in our model to account for more explained variation. It reduces the error variation, where a continuous predictor in the regression perspective is something that we actually control for or adjust the variation for, but we're also able to set up a test of hypothesis for that particular variable as a predictor of whatever we're trying to predict. So, guys, I'm going to keep this one short. I went over on the last one. Well, this is the end of this video. So, man, have a good one. Well, I guess I'll see you guys on Friday.